Hello everyone, my name is Robert and today I will be going over my project on corridor optimization for Transjakarta. And these are my agendas. So starting off with the introduction, I will be explaining about what Transjakarta is about. So the project, it analyzes the Transjakarta smart card transaction data together with the route and corridor information. So for each trip, the data includes when and where a passenger taps in, when and where they tap out, which corridor they use, and how much they pay. So by aggregating this information, the project will evaluate the travel demand, trip duration, revenue, and patterns of the passenger behaviors. So what is the main problem? The main problem is that the Transjakarta does not have a simple data-driven way to compare the corridor performance. As in, like, the some routes may be very busy but slow and unreliable. Others may be lightly used but still consume the resources. So what is the solution? The solution proposed here is to engineer a set of corridor level performance metrics from the smart card data, then use them to rank and group the corridors. This will make it easier to see which corridor are high demand and efficient, which will help in finding out what the low demand and need to rethink itself. So what are the main objectives? The first is to quantify the corridor performance by using the metrics as in, for example, like the demand, travel time, revenue, and the passenger behavior. Second is to group corridors into performance tiers so that high performing and low performing routes can be easily distinguished. Third, to generate actionable insights and recommendations that can feed into the business plan for Transjakarta corridor plan. So now we'll be talking about the data cleaning and data understanding. So the data set consists of several components: tap in information, tap out information, corridor, and route details. So the tap in records contain the boarding time, the stop name, and all of the above. The tap out records provide similar information for the lighting stops, which allows the calculation of trip duration when combined with the tap in times. The passenger level data includes a unique card ID and some demographics attributes, and payment data records the fare amount, include cases where the fare is zero for free rides. Now, what are some of the missing values? So like most real-world data sets, this one contains quite a few of the missing values. So some trips are missing the payment amounts, some are missing the tap-in or tap-out stop details, and in a few cases, corridor identifiers or names are incomplete. Uh, if these gaps are not handled properly, they can bias measures such as the total trips, average duration, revenue, and even the identification of which corridor a trip belongs to. So how did I handle the missing values? So different strategies were used depending on the type of the missing data. But for the missing payment amounts, I averaged the fares per corridor because can be used to input the reasonable values while keeping trips with truly free fares recorded as zero. And one more example is the for missing tap out times and locations. If duration cannot be estimated, then those records are excluded from duration based analysis to avoid the distorting the results. Now I will summarize the feature engineering part. So basically, to move from raw transactions to corridor performance, 12 new metrics were created at the corridor level. Now, for travel time, there are metrics such as the average trip duration, median trip duration to reduce the effect of outliers. On the revenue side, the total revenue and average revenue per trip show how the financially important a corridor is. And the for the passenger behavior is captured through unique passengers, which counts how many distinct users travel on a corridor, and measures like peak hours and weekend usage ratio. So I use this performance score approach because there are many separate metrics, and a composite performance score was created to provide a single number for each corridor. So basically, each metric is first scaled, so they are comparable range, then combined with the weights. For example, placing the slightly more weight on the man while still rewarding good travel times. So the final score allows corridors to be ranked from best to worst, making it easier to focus on the top performers and really create a plan for the underperformers and support the decision about where to invest or to intervene. And now we're going to the EDA part. So this is the graph or the bar graph for the busiest corridor. So some key insights is that the busiest corridors typically connect to a large residential areas to major activity centers, such as the CBD area. So this confirms that demand is strongly location-based dependent. Routes that link dense housing areas with job centers attract highest volumes. And it also highlights which corridors must be prioritized when planning the fleet allocations. Now, this is a bar graph about the most profitable corridors. So some key insights on this graph is that after a first few, revenue seems to have dropped more gradually across the remaining top corridors, which suggests a long tail pattern where a small number of routes provide a large share of income. Comparing this with the busiest corridor chart reveals that the high usage does not always mean the highest revenue. And this is a graph to show the top performing corridors. Now, what can be drawn from the top performing corridors from this graph is that from these top performing corridors, we can see that a strong location, reliable travel times, and good revenue performance tend to go together. Now, a better way to group each corridors is by doing this corridor grouping mechanism. So the corridor are grouped into four main categories: high demand and high efficiency, high demand but low efficiency, medium demand but medium efficiency, and low demand with low efficiency. So for the first one is the stars of the network and should generally be maintained and protected. So the second one carry many passengers but have slow or unreliable service. They are prime candidates for schedule adjustments and additional buses or express services. Now, the medium demand corridor offers growth potential with the right marketing or better integration. Now, the low demand, low efficiency corridor may need route rationalization, such as converting them into feeder lines or merging them with better performing routes. Now, what can we create a plan on based on the results? So the first one is the high demand corridor optimization. So the plan is to maintain strong service quality and protect reliability, especially during peak hours. For the for the medium demand corridors can be supported with the marketing campaigns, better weekend offers, and stronger integration with major routes to attract more riders. And the low demand corridors should be reevaluated. So this is the persona. His name is Andy, and he chose Transjakarta to save time and money, but he struggles with the long queues and difficulty getting the real time information. So to improve on this, we we will show that the like a high demand corridors can be shown more, better peak time management and clearer information would directly improve his daily experience and encourage more people like him to use the system. So in summary, the smart card transaction data can be transformed into meaningful corridor level metrics that reveal demand and revenue patterns. And the performance score and grouping mechanism make it easier to identify which corridors should be maintained, improved, grown, or restructured. And by following this proposed business plan, the Transjakarta can allocate resources more efficiently. And thank you very much for this time and have a good day, everyone.